Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video, we are going to have a look at the drum brake. Principle of operation, construction, and component parts of the drum brake are going to be covered in this video. Well, this is a very typical leading trailing type drum brake assembly. When you look at the component parts, the massive drum-like structure that is going to rotate with the wheel is called the drum. This is a metal part on which friction takes place in order to reduce vehicle speed. This drum will be rotating with the wheel. It is the one that is going to transfer the engine power from the axle to the wheel. See, there are lug nuts to be included here. There are bolts, tire installing bolts to be connected here. So this drum is rotating with the tire. Now, when you remove the drum, you will find the drum brake components. Right here we have the drum brake components. Here we have the leading shoe. Here we have the trailing shoe. Leading shoe, we call it the leading shoe because when the vehicle is moving forward, this is going into that direction of travel, but this one is a trailing shoe which is following behind. So we call this the leading shoe and we call this the trailing shoe. These are the brake shoes. This C-like structure is called the brake shoe. This C-like structure is called the brake shoe. And onto the brake shoe, we have a asbestos material. We call it the brake lining. This is the one that is constructed from asbestos, and this is where friction is taking place. Actually, this is the material that is going to be pressed onto the drum, onto the rotating drum, in order to generate friction and reduce vehicle speed as a result. So we have two shoes for this particular vehicle. We have a leading shoe and we have a trailing shoe. And the brake shoes are held together and pressed by the hold-down assembly. This right here is a spring-loaded hold-down assembly. The hold-down assembly is keeping the brake system components pressed onto the backing plate. This metal surface, this black surface on the back, we call it the backing plate. So the brake shoes, they are pressed onto the back plate by a hold-down assembly. Here there was supposed to be a hold-down assembly, now it is missing. And when these brake shoes are pushed out by a hydraulic pressure, hydraulic force is exerted by this piston. Right here we have a piston. When the brake master cylinder is depressed, hydraulic fluid will force this piston in this direction and force the other piston in the opposite direction, pushing this brake shoe onto the rotating drum. So this right here, this black part containing the hydraulic pressure operating mechanism, the pistons and everything is called the wheel cylinder. Inside the wheel cylinder, for this particular design, we have two pistons, one for the trailing shoe, one for the leading shoe. Now the idea is when hydraulic pressure is applied, these pistons are to be moved in opposite direction, forcing this brake shoe to be pressed onto the rotating drum. And when the brake shoes are extended outward, they will be stretching this retracting spring. This is a return spring. We have two of them, one on the lower side and one on the upper side. So when the brake shoe is pushed out by hydraulic pressure, this spring will stretch, and when you let go of the brake pedal and hydraulic pressure is removed, this will return the brake shoes to their original position. And the brake shoes on the upper side, they are operated by the hydraulic piston. On the lower side, we have pivots. Right here, we have pivots on which the brake shoes are pivoted. So down there, we have a pivot. And this assembly also have a parking system, a parking brake mechanism. As you can see right here, we have a parking brake cable. When the parking brake is applied, you will be pulling this cable, and that cable will activate this parking lever. When the parking lever is moved to this direction, it will force the strut. This is the strut. So when this is pulled, it will force the strut, and the strut will force the leading shoe onto the drum. The idea is when this lever is pulled, it will pivot right here. There is a pivot on the upper side. It will pivot right here, and then it will move the strut. And once the leading shoe is pressed onto the rotating drum, the drum which is supposed to be right here, once it is pressed onto the rotating drum, the strut will stop moving further. Then what will happen? This lever, initially it was forcing the strut to this direction. Now because this point is not moving, because this point has already stopped moving, this end will move in the opposite direction. This will serve as a fulcrum on the second phase. This strut will act as a fulcrum for the lever. this end will push the trailing shoe onto the drum. So that way you can park your vehicle. So parking brake is activated by a cable. There is a parking brake cable right here. When this lever is pulled, it will operate the strut to activate the trailing shoe onto the drum. And once this has stopped moving, the lever will pivot right here, and this end will move in opposite direction, forcing the trailing shoe onto the drum. So this is how the parking brake is activated. And when the parking brake is released, this will become free again. It will be free, then the lever will be returned, and these springs, they will return the entire assembly back to the zero position. Now, as the brakes operate, the lining material will start to wear out. This will start to wear out, and this lining will wear out. Now, what will happen? The gap between the brake shoe and the drum will increase, and that will reduce braking performance, and that will increase response time as well. So in order to avoid that, these type of brakes, they have an adjusting mechanism. Right here, for example, we have an adjusting eccentric. This is an eccentric. When this eccentric is moved in clockwise direction in such a fashion, as you can see, the diameter is increasing from the center point. This right here, we have a small diameter. As you go along, the diameter is increasing. So this will force this drum onto the drum direction. It will force this brake shoe onto the drum direction. Similarly, we have an adjusting knob for this trailing shoe as well. So by simply rotating this, you can adjust the gap. When the brake lining is new, it has to be at the minimum. As it wears out, we will have this adjustment in order to make the brake shoe closer to the drum. Other types of drum brakes have a star adjuster located somewhere around here on the lower side. By simply moving that star adjuster, you can change the distance between the brake lining and the drum. That is how the brakes are adjusted. But for this particular brake assembly, we have an eccentric cam that is located one at the leading side and one at the trailing side. And when you look at the wheel cylinder, for this particular wheel cylinder, you see we have two pistons and there are seals. Seals are preventing hydraulic pressure from leaking. Seals are the ones that are going to seal brake fluid from leaking out. And on the outer side, we will usually have a boot that is going to cover this dust. Boot is there. And there is a spring, very low tension spring is there. That low tension spring will always make sure that these pistons are pressed onto the brake shoe at all time. So this will keep in contact at all time. It will prevent the piston in this assembly from rattling. So that will press the piston onto the brake shoe at all times. And whenever you are servicing this type of brake, always make sure that you are not blowing it with a compressed air. This asbestos material, due to excessive friction, it will generate dust. Asbestos dirt will be there. Blowing that will send it to your lung. That is very poisonous. So asbestos is very poisonous, even cancer causing. So try to avoid blowing brake system, drum brake assembly with compressed air. Rather, you can simply wipe it with wet towel in order to clean all these dust particles. Asbestos dust, it has to be cleaned in such a fashion. Rather, so always avoid using compressed air. This type of drum brake is used on most passenger vehicles, railway, and on heavy-duty trucks. Heavy-duty trucks are using this type of brake configuration. The only difference is instead of using hydraulic pressure, this will be operated pneumatically by compressed air. Otherwise, the rest of the construction is the same. You have brake shoes on either side. There is a massive drum that is going to be installed in here. And when the brake shoes are pushed outward, it will exert force, it will exert friction onto the drum. The principle of operation is the same, only the mechanisms that are going to be used will change. On a heavy-duty truck, for example, we have an S-cam. There is an S-cam that is going to act on the brake shoes, that is to be operated by air pressure, pneumatic pressure. There are advantages and disadvantages when it comes to this drum brake configuration. Now, what is the advantage? The advantage is when brake is applied, this leading shoe, when vehicle is moving in forward direction, this leading shoe have a self-energizing characteristics. What do we mean by that? Now, when brake is applied, we have said this will be forced to the front direction, and drum is obviously rotating in this direction. Now, what will happen? The force that is going to be acting on the brake shoe is forcing the brake shoe in this direction, one, and the drum that is rotating in this direction is also planning to take this brake shoe onto that direction path. So what will happen? Now, the rotating drum and the hydraulic pressure are assisting each other. They will be added together in order to force this leading shoe hard onto the rotating drum. That is called the self-energizing effect of the leading shoe when vehicle is moving in the forward direction. If the vehicle is moving in reverse direction, when drum is rotating in reverse direction, that self-energizing effect will be manifested by the trailing drum. Now, due to this excessive friction compared to the trailing shoe, usually the leading side brake lining will run down faster than the trailing side. Why? Because we have a larger braking power, we have a larger friction, and we have a larger force acting on this lining material compared to the trailing one. So that is one disadvantage. We will have a self-energizing effect. Hydraulic pressure is forcing the lining in this direction. The rotating drum is forcing the brake shoe in a similar direction. But because it is prevented from moving further with this pivot, those two forces will press this hard onto the drum, energizing, generating, exerting higher force compared to the trailing. But when it comes to the trailing, when drum is rotating, drum is pushing it away, pushing it in this direction. Hydraulic pressure is acting in opposite direction. But when it comes to the leading shoe, they are assisting each other. When it comes to the trailing shoe, however, drum moving in this direction, hydraulic pressure moving in this direction, they are acting against each other. But when it comes to the leading shoe, they are assisting. So that is the self-energizing characteristics of the leading shoe. That is one basic advantage. Now the disadvantage is because when drum is installed on here, it will become a sealed surface. So ventilation and cooling will somehow suffer due to that. And if water is admitted into this system, if this vehicle is driven in deep water and water gets admitted in here, and that can cause water fade, that can cause the friction to drop, and there is usually no way out for the water to go out, especially if the drum is totally sealed, if the drum is a totally closed surface, if there are no drillings, water that gets admitted into the system will remain here, causing brake fade. The other cause of brake failure on this type of drum brake is excessive use of the brake. Excessive use of the brake will cause the brake to overheat. The drum, when it is overheating, the drum will move away from the brake shoe. It will move away from the brake shoe, one disadvantage, and we will have heat fade on the lining. The asbestos material, when it is extremely hot, will start to be welded on the drum surface, causing the drum surface to be covered with blazed asbestos dust, and the brake shoe lining is also asbestos. Friction now will become between asbestos and asbestos instead of between asbestos and steel. So that will reduce the braking performance. That is why if you are going to be driving a very long steep down, you should be reducing your vehicle speed by shifting down. Shifting down the transmission is a major thing that you have to do instead of always applying brake. That is why you might have heard or you might have experienced vehicles losing brake due to extreme temperature of the drum assembly. So if you are driving a heavily loaded vehicle, you should be using engine braking and transmission gear changing in order to reduce vehicle speed instead of fully applying the drum brake. That will cause overheating, that will cause heat fade, and that will reduce braking performance dramatically. And your vehicle might be out of control. So always be careful. If you are using excessively, this will overheat. And as we have said earlier, ventilation is not there, ventilation is somehow restricted in this type of brake assembly, the brake fade will cause catastrophic brake failure. So that is one main disadvantage. Fade, water fade, when water is inserted in here, when there is water will remain in here, reducing friction, and when it is overheating, excessive use of the brake will cause heat fade. So that is a disadvantage when it comes to drum brake assembly. And whenever servicing, always make sure to check the thickness of the lining material. There has to be sufficient life in it. And when installing these brake shoes onto the backing plate, it is a good idea to somehow apply grease to the surface that is supporting this. The lining, the brake shoe is to be supported on some surfaces. You can grease those in order to allow for smooth operation and smooth sliding of the brake shoes. And some parking mechanism on this type of drum brake have an automatic clearance adjusting mechanism. This brake doesn't have that kind of alternative, but on some, there is a star adjuster that is going to be activated every time you pull parking brake. Every time parking brake is applied, there is a star adjuster that will self-adjust. Those are automatic adjusting mechanisms are there. On this particular vehicle, that is not available. So you have to manually adjust depending on the extent of wear on the brake shoes. You have to manually adjust, but there are vehicles with automatic adjustment mechanism. Well, dear viewers, that is all we have for you regarding construction, component parts, and principle of operation of drum brake. If you find this video helpful and if you enjoy what has been presented, don't forget to smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Similar, this kind of videos are going to be uploaded on this channel. You can be a member, subscribed member, and share it with friends. Those are interested in automotive knowledge, share them, and share us your thoughts in the comment section below. Tell us what you think about our video, and any recommendation, any suggestion on automotive related content, let us know in the comment section. If you find it useful, don't forget to smash the like button. That is all we have for you in this video. We hope to see you in another video. Until then, drive safe.